All right, we're in the matrix portion of the practice quiz. So we've been given this equation with the two matrices, excuse me. We got to find the value of k. So this is just really making sure you understand positional, the positional rules, and all that stuff for matrices. So if these are the same, they're clearly 2 by 2s. If I'm looking for k, basically I'm in this position and I'm in this position, and I just say -2 equals k plus 1. That's all. Okay. Subtract 1 from both sides. K will be -3. Boom, pow, you're done. Cool. Let's do the next one. All right. This one we're given two matrices. Okay. We have all this information here, and they say, I want you to find me matrix A minus 1/2 of matrix B. So step one, what you have to do is you're multiplying matrix B by the scalar of 1/2. So if I did that, if I multiplied in the scalar affects each term individually. So 1/2 B would be equal to, well, half of 2 is 1. Half of -2 is -1. Half of 4 is 2. Half of 1 is a half. Half of 6 is 3. And half of 0 is 0. So that's that first part. So now I was saying, well, I want you to take matrix A and subtract from it that result. So essentially, we're saying we're writing down matrix A now. I'm going to subtract it with matrix B. And now this is, remember, understanding all of our positional stuff. So our answer is going to be here. We'll just fill it in. -1 minus 1 is -2. 1 minus -1 is like saying 1 plus 1, so that is +2. 2. Oh, I made a mistake here. I'm so sorry, guys. Half of 4 is not 4 ever. It's 2. There we go. Sorry about that. Let's keep it going. 2 minus 2 is 0. 3 minus 1/2 is like saying 2.5 or 2.5. Or you can say 5 over 2, as you like. -1 minus 3 is -4. And 4 minus 0 is 4. Voila. Yeah, I guess I can do this. So matrix A minus 1/2 of matrix B equals, big equal sign, equals that. And there you go. Ta-da! Oops, there we go. Ta-da! There we go. Let's go to question number 5. All right. Amazing transition done. Time to tackle this problem. All right, here we go. Number 5, it says find the value of x such that all this information is a singular matrix. Okay, so this first depends on us understanding that a singular matrix is just when the determinant equals 0. So it's like saying this. The determinant of this information equals 0. That's it. That's what the question's saying to do. Take the determinant, set it equal to 0, and then go ahead and find x. All right. So finding the determinant here, we take these values and multiply them. So that's here and here. That's x squared. Okie dokie. Minus these values here. And we're going to parenthesize this whole thing to avoid a common mistake here. Because what's going to happen here is going to say like -3 is multiplied by 2x plus 3. And that all happens there. Okay. So if I distribute that, or if I rewrite it, it's going to say, well, -3 times 2x is -6x plus, and that's -3 times 3 plus -9. Okay. Now this minus sign right here. Remember, subtracting is just like adding a negative, so it's just like saying plus the negative of all this information. So in reality, we're going to get left with the quadratic, which is just going to say, shoot, x squared, a negative times a negative is a positive, plus 6x, a negative times negative is a positive, excuse me, that negative times that negative is a positive, plus 9. So that's that. That's our determinant, and it's going to equal 0. Okay, so now all we got to do is factor this and find our solution. So factoring this, we can see pretty fast it is a perfect square quadratic. Okay, so this is just going to be x plus 9. Excuse me, x plus 3, because it's a perfect square quadratic. Just to clarify real quick, this x plus 3 is because the square root of x squared is x, and the square root of 9 is 3, and so we put that square there to acknowledge what we did. And if I multiply that out, we'd get right back where we started. That equals 0. We take the square root of both sides. We get x plus 3 is the square root of 0, which is 0. And you find x is negative 3. There we go. Ta-da! Let's go to the next question. Okay, so it says they want me to find the value of h and k. So we have these two matrices multiplying, and we're getting this result. And this one can be a little tricky, so it does really benefit us in this case. You know, we could go through all of the place value multiplication and be super careful and lay it all out. But in this case, you know, it might just benefit us to move a little faster and just know that we're just going to say 3h plus 4k. It goes there, that goes there. That's going to equal 11. Same pattern, negative 1h plus 2k. Okay, that's going to equal 13. Okay, so now we got two simultaneous equations. We could solve this a whole bunch of different ways. We could isolate h and substitute back in. But in this case, I think it may be easier just to multiply every term down here by 3 and do some elimination. So if I multiply every term down here by 3, I'm going to rewrite this top one first. I'll say 3h plus 4k is 11. If I multiplied all of these by 3, I would get negative 3h plus 6k equals, that's going to be 39. So I'm just going to add these all together. These will 0 out. I'm going to get 10k equals, what's that going to be? 50. Divide both sides by 10, and k equals 5. So we know right here, all right, k is 5. So now we can actually just substitute that in to either one of these and solve. I'm going to probably do this one because it looks a little bit easier. If I substitute in a 5, I'm going to get negative h plus 10 equals 13. I subtract 10 from both sides. I get negative h is 3. Divide both sides by negative 1. I would get h is negative 3. Okay, there we go. Ta-da! We got our answers. We did it. I think we're all done with matrices for now. Let's keep it going and see what's next.